What if I told you that locked within a frozen world smaller than Texas lies geological wonders that rival Earth's Grand Canyon? Saturn's moon, Dione, has been hiding in plain sight, its icy cliffs and mysterious fractures telling a story that NASA hasn't fully revealed to the public. Picture cracking open an ancient treasure chest. That's what exploring Dione feels like. What lies beneath those glittering fractures? Could something be stirring in a hidden ocean? The Cassini mission gathered intriguing data, and scientists reconsidered everything about these distant icy worlds. The forgotten moon, Dione's position in Saturn's family. When we gaze at Saturn through a telescope, our eyes are naturally drawn to its magnificent rings and its largest moon, Titan, shrouded in its mysterious orange haze. But hidden among Saturn's family of over 200 satellites lies a celestial body that deserves far more attention than it receives, Dione, the fourth largest moon in this vast lunar collection. Despite being more massive than all but 3 of Saturn's moons, Dione exists in the astronomical shadow of its more famous siblings. While Titan commands attention with its thick atmosphere, and Enceladus dazzles scientists with its dramatic southern geysers, Dione quietly orbits Saturn at 377,400 kilometers. This unassuming moon occupies a gravitational sweet spot that has shaped its destiny in fascinating ways, like a diamond in the rough waiting to be discovered. At 1,120 kilometers in diameter, Dione's modest size belies its geological significance. The gravitational forces at play have kneaded and stretched the moon's crust over billions of years, much like tidal forces shape Earth's oceans, creating surface features that defy expectations for a world of its dimensions. Dione's role as the middle child of Saturn's moon system makes it special. Although it may lack the immediate visual appeal of its siblings, it potentially holds the most crucial evidence about how the entire Saturnian system formed. Its composition, orbit, and unique geological features tell a story that its more famous siblings cannot. A moon with history, Giovanni Cassini's overlooked discovery. Let's return to a chilly March evening, 1684, at the Paris Observatory, where Giovanni Domenico Cassini peered through his primitive telescope at Saturn's magnificent rings. On that fateful night, March 21st, the Italian astronomer spotted a tiny flicker of light, a speck so modest it seemed almost insignificant against the grandeur of Saturn itself. Yet, this humble observation would ultimately add another celestial body to our understanding of the solar system, though its significance remained veiled for centuries. Cassini's discovery remained anonymous for generations. For over 160 years, this world existed simply as Saturn the fourth in distance from the ringed planet, with no identity beyond its orbital position. Constrained by the limitations of early telescopes, astronomers could merely track its movement as a distant point of light, its true nature completely hidden from human eyes. The transformation came in 1847, when English astronomer John Herschel proposed adopting Greek mythology names for Saturn's moons. Saturn IV became Dione, named after a Titaness described variously as the daughter of Oceanus and Tethys, or as Zeus's consort and Aphrodite's mother. This created a perfect parallel. The Titaness Dione existed somewhat in the shadows of more prominent deities, while her celestial namesake remained overshadowed by more famous moons despite its significance. This centuries-long period of anonymity makes Dione's eventual exploration profoundly meaningful. Mystery preceded our first real understanding of its nature, giving this moon a rich historical narrative long before we could even see its face. From dot to world, the Voyager missions transform our view. Those centuries of mystery finally gave way to revelation in November 1980, when Voyager 1 streaked through the Saturnian system at a breathtaking 40,000 miles per hour. In an instant, Dione transformed from a mere point of light into a world with distinct features and a personality all its own. The first close-up images beamed back to Earth revealed a moon that refused to be ordinary, a celestial body with a split personality that immediately captivated planetary scientists. Voyager's cameras unveiled the striking, wispy terrain, ghostly bright streaks crisscrossing Dione's surface like cosmic scratches. These mysterious markings were completely unlike anything previously documented in our solar system, leaving researchers baffled. What cosmic forces could create such distinct patterns on an icy moon? As the spacecraft continued observing, Dione revealed itself as a world of stark contrasts. The trailing hemisphere, facing away from its orbital direction, displayed the scars of countless impacts, including the massive 350-kilometer Evander crater. Significant impact sites like Aeneas and Dido, named from Virgil's Aeneid, punctuated the battered landscape. Meanwhile, another hemisphere appeared surprisingly smooth, creating a dramatic dichotomy, begging for explanation. Though groundbreaking, Voyager's brief flyby offered only tantalizing glimpses. The spacecraft measured Dione's precise diameter and determined its density to be about 1.48 grams per cubic centimeter, suggesting a composition of primarily water ice with a rocky core. These initial measurements, however, only deepened the moon's mystery. The Cassini Revolution, uncovering Dione's secrets. Those tantalizing glimpses from Voyager would prove to be merely the prologue to Dione's true story. In 2004, the Cassini spacecraft arrived at Saturn, equipped with instruments capable of revealing truths that would transform our understanding of this distant world. Unlike Voyager's brief encounter, Cassini would conduct multiple close flybys over its 13-year mission, coming as close as 99 kilometers from Dione's surface, close enough to see details invisible to previous missions. The first revelation came when Cassini's high-resolution cameras showed the true nature of those mysterious, wispy terrains. They were enormous ice cliffs hundreds of kilometers long and several kilometers deep, massive fractures in Dione's crust that signaled geological forces powerful enough to crack a world. These Chasmata completely rewrote the story of Dione's geological history. Cassini also discovered an oxygen atmosphere surrounding Dione, 5 trillion times thinner than Earth's, with roughly 1 oxygen ion per 0.67 cubic inches of space. We now know that Dione, in addition to Saturn's rings and the moon Rhea, is a source of oxygen molecules, noted Robert Tokar of Los Alamos National Laboratory, adding that this oxygen could form through processes entirely unrelated to life. Yet even these findings paled compared to Cassini's most profound discovery, subtle gravitational measurements that, combined with models of Dione's internal heat budget, suggested a liquid water layer hiding between its rocky core and icy crust, a subsurface ocean. Palatine Chasmata, ice cliffs to rival Earth's Grand Canyon. While a potential subsurface ocean captured headlines, Dione's surface tells an even more dramatic story. At temperatures approaching -187 degrees Celsius, water ice behaves like solid rock, allowing for geological formations that defy our Earth-based expectations. The most spectacular of these features is Palatine Chasmata, a system of enormous fractures stretching over 600 kilometers across Dione's frozen landscape. Standing before these ice cliffs would be like witnessing Earth's Grand Canyon, reimagined as a crystalline fortress. Towering walls of solid ice, extending kilometers upward, their bright faces exposed where darker material has fallen away. These massive geological monuments, proportional to Dione's size, make our planet's most impressive canyons seem modest by comparison. What's genuinely perplexing is how such massive features formed on a world once thought geologically dormant. These fractures cut through existing craters and surface features, revealing their relative youth in Dione's timeline. Scientists theorize they emerged from global stress patterns as a subsurface ocean gradually froze, creating immense tension in the outer shell. The constant stretching and squeezing from Saturn's gravitational pull generates heat and stress, fracturing the surface on a massive scale. These ice canyons may represent a mature version of the famous tiger stripes found on Enceladus. The Palatine system joins other impressive fracture networks like Padua Chasmata and Carthage Fosse, creating a world laced with ice canyons, each telling a story of unexpected geological violence on a moon that should be long dead. The cosmic dance, Dione's orbital resonances, and moon companions. If Dione's ice canyons suggest a world that refused to die, its orbit reveals why. Saturn's moons don't merely circle their parent planet, They interact through a mathematical ballet that generates enough energy to transform frozen worlds. Dione's perfectly circular orbit, tilted just 0.02 degrees from Saturn's equator, creates the stage for this cosmic performance. The most entrancing relationship exists between Dione and its smaller neighbor, Enceladus, locked in what astronomers call a 2-to-1 mean motion resonance. For every orbit Dione completes around Saturn, Enceladus circles exactly twice. This gravitational partnership has profound consequences. Their rhythmic celestial dance generates tremendous tidal forces, creating internal heat within both worlds. While Enceladus expresses this energy through its famous South Pole geysers, Dione channels similar warming that has shaped its geological story. Dione truly stands apart as host to its own mini-satellite system. Two small moons, Helene and Polydeuces, accompany Dione like loyal courtiers in a cosmic procession, occupying special gravitational sweet spots called Lagrangian points. Helene orbits 60 degrees ahead, while Polydeuces follows 60 degrees behind. Perfect gravitational balance points, where Saturn and Dione's combined forces create stable havens for these tiny companions. The gravitational web extends further, with Dione interacting with Mimas and other moons in Saturn's system. These precise orbital relationships position Dione as a key planetary gear in Saturn's grand clockwork, influencing the evolution of multiple worlds around it. The hidden ocean, evidence for liquid water beneath the ice. Those gravitational forces shaping Dione's orbital dance have created something far more extraordinary beneath its fractured surface. What began as subtle anomalies in Cassini's gravity measurements has evolved into one of the most compelling mysteries in our solar system. During its close flybys, Cassini detected variations in Dione's gravitational field that couldn't be explained by a solid ice structure alone. These fluctuations pointed to something denser beneath the crust, liquid water. Cassini's magnetometer also captured a weak but clear interaction between Dione and Saturn's magnetosphere, suggesting a conductive layer underneath. This is exactly what we'd expect from a salty subsurface ocean, like discovering a vast underground lake beneath what appears to be a wholly frozen landscape. Salt water conducts electricity better than fresh water or ice, providing a second line of evidence for Dione's hidden sea. Scientists believe this ocean lies about 60 miles beneath Dione's icy shell. Models based on Cassini's findings led the Royal Observatory of Belgium to confirm that gravity data from recent Cassini flybys can be explained if Dione's crust floats on an ocean located 100 kilometers below the surface. This body of water surrounds Dione's rocky core. This boundary between water and mineral-rich rock makes Dione potentially special as a habitat. As researcher Attilio Rivaldini explains, the contact between the ocean and the rocky core is crucial. Rock-water interactions provide key nutrients and energy sources, both essential ingredients for life. Dione's ocean has potentially remained stable for billions of years, giving biochemical processes ample time to develop. The next chapter: future missions to uncover Dione's remaining mysteries. Our most significant discovery and frustration is the tantalizing vision of Dione's potential subsurface ocean. Since Cassini's dramatic plunge into Saturn's atmosphere in 2017, our window into the Saturnian system has remained firmly shut. The scientific community faces an agonizing reality. Our understanding of this enigmatic moon is frozen in time, based entirely on the limited encounters from the Voyager and Cassini missions. Behind the scenes, the quest to return to Dione continues. Two promising mission concepts stand at the forefront: the Enceladus orbiter, which would conduct strategic flybys of Dione while studying its more active neighbor, and the Journey to Enceladus and Titan (JET) mission, which recognizes the interconnected nature of Saturn's satellite system. These future explorers must address the profound questions Cassini left unanswered. Does a vast liquid ocean exist beneath those ancient ice plains? How do the massive Chasmata form without current geological activity? Could life thrive in the darkness between water and rock? Does Dione's ocean connect to the surface through hidden fractures? The challenges are substantial. Spacecraft must survive extreme cold, generate power vast distances from the sun, and develop instruments capable of peering through miles of ice. For landers, touching on an irregular frozen surface at minus 187 degrees Celsius demands revolutionary engineering. Could these innovations unlock how life might emerge in the cosmos? Might Dione hold answers about our own origins that we've never imagined? In the vast collection of Saturn's moons, Dione is a testament to cosmic deception, reminding us that size doesn't determine geological significance. This frozen world challenges our understanding of what drives activity on celestial bodies throughout our solar system. Dione, smaller than Texas, yet showcasing fracture systems rivaling Earth's grand geological features, potentially harbors an ocean beneath its icy shell. These overlooked middle children of our solar system may redefine where life could emerge. What cosmic revelations await in worlds we've dismissed as ordinary? Join us in exploring these celestial frontiers, where each discovery expands our understanding of the universe we call home. If you're as fascinated by space as we are, you won't want to miss these other videos. We dive even deeper into the universe's secrets and explore recent discoveries that could revolutionize your understanding of the cosmos. Thank you for joining us on this cosmic adventure. Stay curious and keep looking up.